Hi there. So today we'll study the topic of average and instantaneous velocity. Now what's the meaning of average instantaneous velocity? Now what's the meaning of average clearly? Average means, if let's say you're finding out average of 10 numbers, 10 natural numbers let's say, then what you'll do is, you'll add all those numbers and divide them by 10. Similarly, if you're talking about average speed or average velocity, you'll have to add up all the distances or all the displacements which are available divided by time. So what is average velocity and average speed? Average speed is sum of all the distances, or you can say the actual path length from initial point to final point divided by the time taken, the total time taken is the average speed. Now when you talk about average velocity, which we'll talk about extensively, then average velocity is basically V with the subscript AVG. So this is how we denote average velocity. This will be equal to total displacement divided by total time. Now what's the meaning of this? Let's try to understand this with a simple example. A person started moving from here, and for the same purpose, let's say Sam. Then Sam started moving from this point. After 1 second, Sam is here. Then when I'm observing it after 2 seconds, Sam is there, and so on. And finally, Sam is at this position. So at 1 second, Sam was here and covered 1 meter. Again after 1 second, Sam was here. He covered, let's say, 2 meters. Then consecutively, he covered 1 meter and finally reached the final point. Now if I'll ask you what the average velocity for Sam was, then you will say average velocity will be equal to total displacement covered by Sam, and that will be 1 plus 2, and let's say these are 3 1 meters, so 3 into 1 meters for example we are taking. So 1 plus 2 is 3 and plus 3 is 6. So total displacement from this point to that point is, let's say, 6 meters. How we got this 6 meter? We added all the individual displacements and we got the net sum divided by the total time taken is, let's say, 1 second and 3 seconds for this. So altogether you will get 2 seconds and plus 3, 5 seconds. So total displacement covered was 6 meters. Total time taken was, let's say, 5 seconds. So what we did here, we added all the displacements and we added all the times and we divided time from the displacement and we are calling it average velocity. So average velocity is total displacement by total time. Let's take another example to understand the same point. Let's say a particle starts from here and moves like this and reaches this point. Then net displacement will be this distance, and which we know, if this is a semicircle, then the distance will be the diameter. So if I'll ask you that what was the average velocity for this particle or for this person as such, then you'll write down V with a subscript average, which denotes that we are talking about average velocity. Net displacement is equal to the diameter, which is the total displacement from A to B, and divided by the time taken from going from A to B. So this is how we define average velocity. So average velocity is net displacement by time taken. Let's take another example for average velocity to make the point clear. So let's say a particle moves in a circle and reaches back to the same point. Then Net displacement in this case is 0. So average velocity in this case will also be 0. Another case for average velocity 0 will be, if let's say you are throwing a ball from ground and the ball goes like this and comes back. Then at the end of the motion, if I'll ask you what the average velocity was, you will say the average velocity is 0 because the net displacement is 0. So what is average velocity? Average velocity is the total displacement or net displacement divided by the time taken. If net displacement is 0, then average velocity will be 0. If net displacement is non-zero, then average velocity will be non-zero, provided time is non-zero. Now, if let's say I'll have to define a term called instantaneous, then what is the first thing that comes in your mind? Instantaneous means something at an instant. That means the point where you have fixed your time. So you are talking about a point at a fixed time. That is the meaning of instantaneous. At that particular instant, what a particular parameter is, that is what you call instantaneous. Now, let's say try to understand instantaneous velocity with the help of an example. So let's say I'm having Sam who is moving, let's say with some average velocity v or some speed it's moving. Now when the Sam is here, let's say the time here was t seconds, or in your watch let's say it's 12:30 or something, whatever you want to feel like. So at a fixed time, let's say Sam started running fast. So if I'll ask you what the velocity of Sam is at exactly 12:30, not anything before that, not anything after that. So exactly at this instant, what the velocity of Sam is. Then you'll say, how I can find out? Then somebody will say that if we'll click a picture of Sam at this particular instant and we'll try to find out velocity at this instant, then we can call it instantaneous velocity. I'll repeat my point, that if a person is moving along a particular trajectory following a particular path, then if you will try to find out velocity at a particular instant, then can we call it instantaneous velocity or not? And the answer is a clear-cut no. Answer is a clear-cut no. So this is something which you will have to keep in mind. By instantaneous velocity, we do not mean basically that velocity at an instant. This is not the correct statement. The correct statement is velocity for a small displacement. Velocity for a small displacement in a small amount of time is what we call instantaneous velocity. It's not velocity at an instant. So this statement is incorrect, that velocity at a point is instantaneous velocity. Now why is it wrong? I'll justify you that. That is wrong because the definition of velocity is net displacement by time. What's the definition of velocity? Net displacement by time. Now when we can have net displacement? If we have non-zero time. Net displacement can only be there when there is a change in position. If there is no change in position, you cannot have net displacement. And since you cannot define displacement, or you cannot define non-zero displacement, you cannot define velocity. So if I'm talking about a particular point at a particular instant, there are no two positions. And if there are no two positions, you cannot define a net displacement, you cannot define a velocity. So you can only define non-zero velocity when there is a non-zero displacement. And a non-zero displacement can be small, can be really tiny, but cannot be zero. So you need 2 points in order to define velocity, and since if you are talking about a particular instant, you cannot define those 2 points. And since you cannot define those 2 points, you cannot define the displacement between them, so you cannot define instantaneous velocity. So whenever in your book you will find the term instantaneous velocity, that basically means you are talking about really tiny displacements. So what is the meaning of instantaneous velocity? The meaning is, if I am talking about Sam's motion for a very small distance, it's, let's say, this length magnified. So I have magnified this distance. So this is, let's say, 1 nanometer something. So if I am having this much small distance, really small distance, so this is 1 nanometer, which is a really small distance. If we are talking about this much small distance covered in, let's say, really small time, so let's say 1 nanoseconds, then if we are defining velocity for this magnitude of displacement, that is 1 nanometer divided by 1 nanosecond, then we can call it instantaneous velocity. You don't have to go deep into it, you'll just have to understand the meaning of it. Instantaneous velocity doesn't mean velocity at an instant, it just means that for a small displacement and for a small time, what is the rate? And that is the instantaneous velocity. So now we got a clear-cut distinction between average velocity and instantaneous velocity. Let's recapitulate all these things and let's start from velocity. So velocity was net displacement by time taken for that displacement. Now we have further categorized into two parts. One was instantaneous, another one was average. Average velocity is the velocity when you are taking the total displacement by total time, which is same as the definition of velocity which you studied earlier. But there is a catch in instantaneous velocity. When in average velocities displacement becomes really small. So when in average velocity displacement becomes really small, such that the distance between those 2 points into consideration becomes 0, or is it the correct statement? No, it's not, because it does not become 0, it tends to become 0. So it will seem as if it's becoming 0, but it is not 0. That is something which you keep in mind. So instantaneous velocity is not the velocity at an instant. Instantaneous velocity is the velocity when the displacement becomes really small and time also becomes really small, such that the length and the time is tending to 0. It's not 0. That's the point which you need to remember. And then that velocity is what you call instantaneous velocity. So I hope you got the picture. So this is the average velocity, which is total distance, total displacement by total time, and this is the instantaneous velocity when the total displacement becomes really small and total time is also really small but not 0, then we call it instantaneous velocity. So keep all the things in mind and see you in next class. Thank you.